Hello, well, I'm Andreas, or Luca, from the net. Maybe some of you on YouTube you know. I just want to explain the Geet machine as I did in Amsterdam. So here's a working model, so everybody can make something, and I just want to explain in a short way. It's a standard generator, but just bought from the shop, and the point is, the Geet machine, like Geet Pantone explained, is in the part right, but in the part it's a bit different. So basically you can see here the liquids. In the lower part you can see the water. In the upper part you can see the gasoline, because gasoline is lighter. The hot air is coming in from here, going down to the bottom, and so it's bubbling. It will bubble up and mix the water and the fuel together. And this fuel mixture is running through till the reactor. This reactor tube is surrounded by the escape. So it's getting hot inside, because the hot escape from the motor is just running through it.
You mean the exhaust?
The exhaust, sorry, not escape, the exhaust. Wrong word. And so the exhaust is heating up the intake where the water and gasoline mix. Running directly into the motor without no carburetor is not necessary, because this is a stationary motor. And well, I think the best would be just to show you now how it works. Can somebody hold it? Yes? Thank you. Oops. Open the valve a bit. We have to oops, sorry, he's coming. Water out. It's water, yeah. Oh, and the transport. Okay, have a look, have a try.
Yes?
Yep. So when you see here in the bubbler, the water is mixed with the gasoline, and you can see that the kit of the question is there's a vacuum. So this vacuum makes that the water evaporates at a much lower point, and this is a very, very, very easy thing. Everybody can do it, and the important thing is, if you look here, you now there's some water drops coming out because of transport, but you've got no fumes at all with contamination. So the important thing is you can drop down contamination. So this is wait a second. I want to lights, no. We have here the lights. Okay. Well, what's the differences? What are the differences? First of all, we've got a very big difference in the exhaust fumes. So we measured about 0.13 or 0.3 instead of 2 of CO. So the CO went down. And the combustion, we need not 1.7 liters an hour, we need 0.3 under 2,000 watts of charge. So it's about nearly 7 times less when you made. What is going on? Actually, you're using the heat that the exhaust generates to heat up, and all this energy is used. So it's not a free energy invention, it's just a more efficient energy. And this energy you can do with just some plumber device. Everybody can do it. Our idea is to bring it to the third world where the people are interested to, because usually in our world we just want to buy it and that's it. In the third world, I had cards from India and from other places. They are very interested in, because the water pumps they're running their field and they're flooding their fields to make rice. And the pollution is a very big issue, because you have all the smoke on the fields. And the other big issue is that you have not enough money, because for somebody in the third world to pay 17 liters or to pay 3 liters is a big difference. The other interesting thing is the motor does not get hot at all. I can still touch it, and usually I would get burned. I am not, and this is just because it's the more efficiency, it's the heat. You use the heat to make it. How? In a normal motor, you have a big explosion to push down the piston. So the piston goes down, and because of the explosion creates heat. Here inside, we've got a little explosion, and we've got vapor going inside the piston. If you put hot vapor inside the piston and the piston rises, in the moment of the hottest compression, you've got some water drops on the piston. Then the ignition starts, and the little bit of fuel makes that at 900 degree warmness the water turns to 2000 nearby. That makes immediately that the water turns steam. Steam has a very high pressure grade. It's the energy is 2088. So at 100 degree, imagine at 2000. And the steam is not making an explosion. Steam making an expansion. So what's the difference? In 2 words. The usual motor uses gas for doing explosion, and we are using gas to make a little explosion with a big expansion. This is the big difference. If you make the expansion, the motor cools down, you have no toxic fumes, or less toxic fumes at least, and you can solve a lot of energy problems in the world with just 3 or 4 parts of plumbery. And that's all the secret. There's nothing else. There's no magnetic field. You don't have to put it north-south anywhere. You don't have to pray mumbo jumbo. It's just working, and so everybody can do it anywhere.
Now, are you giving out plans that?
Yes, all the plans. Yes, all the plans you can find on hydronica.blogspot.com, or if you look in YouTube, there you can see the videos in Aluka 1603 in the channel Aluka, A-L-U-K-A 1603 on YouTube, where I put everything open, because I think this is something everybody should know, and it's just my little bit to change the world.
Now, how much did it cost to make this modification to this off-the-shelf generator?
The modification is 1 to 3 tubes of plumbery and 2 little tees. It could be about $15 or $20, not more.
So I assume you see this also applicable for a car and all of that.
Yes and no. The principle is applicable for a car. The principle of making a little explosion with the water expansion is the same principle. Especially now we are doing this on a very big, huge truck. To make, we will go around the world. It's a new project on a diesel truck. What do? We put some hot steam. It is important. This is hot steam, not cool water, in the machine, so you have no cracking of the metal parts. In some racing cars, they try to put water injection, but this cools down the metal immediately and has thermal problems with cracking. As the steam here is already very hot, about 250 to 300 degrees, so you have no thermal problems, and the water gets all the energy to the piston where you need it for the later expansion. So yeah, there's no loss of energy, and this is why it's so efficient.
And so you are currently modifying a truck, is that?
Yes, this is a 12-ton truck, 4x4 wheeled, military, big one, because lots of people said, well, this isn't very nice to have a small machine, but we want to see really something big going on. I have experiences from France, for example, where there's a website called Quantum, and there's a person, a farmer, his name is Andreas Kalcker. He's really a genius in my mind. So he managed to make a Massey Ferguson tractor, the standard tractor, from 21 liters of diesel an hour. He brought it down to 16, later to 10, and now it's running on 5 liters on diesel fuel an hour with 10 liters of water.
And when is this going to be demonstrated?
This will be demonstrated at the end of the year. We are still working on improvements, because it's not the same making a small motor than a 12-ton truck. So this is applicable to all the others. On the website there are other plans you can download for free, obviously, and you can change it if the law permits it in your country, because in some countries it's not permitted. So, make the world a bit less polluted and use less gas. Well, my decision was to, he's a new owner of the machine, because, he was the responsible that I was having this conference in Amsterdam. Thank you, Herman. And I don't want to bring it back, so he's the new owner, and I will tell him some tricks inside. So, as everything has some details. Come on. Now, this is the input. For example, if sometimes, if you run it, sometimes there may be some condensing water inside. So you started with the machine and you open the additional air throttle. This is not air throttle, it's additional air. Open it to get rid of condensed water. You leave it usually it's just a half turn open on middle. Don't push the liquid higher than this, because if liquid goes direct into the machine, you have liquid in the cylinder. It only has to be gas, you know. If you see that liquid is going to, stop the machine, because if not, you will have a problem with this.
I guess you can break the.
Yeah, right. You can break the pleuel. How do you say this?
The piston and the rods and the
camshaft. Well,
okay.
It always has to be gas. So there has to be no liquid over here. If you put it too high, bad. The important point is, in the air we are sucking into the motor is preheated. Why? In usual Pantone, this is getting very cold. Sometimes too cold, and sometimes it freezes. So cold, because it's a vacuum here. So I preheated it in this. Air comes through, goes down to the bottom and bubbles. So you've got a bubbling mix here, and as this is a space and the motor sucks the air, so you've got a vacuum here. It means that the water is evaporating at a lower point. It does not boil at 100 degrees, it can boil at 60 degrees. Okay. You always, in this machine, a particular machine, you will use more gasoline and less water. Why? Because water evaporates at a different point, and gasoline always evaporates earlier. You know, it's an evaporation problem, nothing else. But even the little bit of water you're using is enough to bring down the consumption. If you want more efficient the machine, heat this up. Just heat it. So the mix goes in here, just through, and goes directly in the machine. There's no other issue. Well, sometimes you have to get rid of condensed water because you have a higher rate of condensing water, obviously, because you're using the water for the expansion. So I sometimes thought to make a little hole in here so you can tap the water out, because the water is not burned actually. Some water is burned as a dissociation because we had higher oxygen readings. And the higher oxygen readings, what does it mean? That at the point of the little explosion with the water drops, some of the water is dissociating into hydrogen, HHO. But it explodes immediately and it burns immediately, reacting again. But it bonds to the carbon and not to the hydrogen anymore. And so you have more oxygen in the output than in the usual motor. That's why. Actually, well, you need the plumbery stuff. This is just 1 inch and ½ inch. If you want to have heavier oils, you need just a longer one. Okay, made it longer and so it's hotter. So the hotter, the heavier could be the mix.
So can this be used with diesel or gasoline?
Yes, diesel you can mix, but you need at least have this on 57 degrees because flame temperature of diesel is 60 degrees, you know. So I would make then a double processor. Let's say one input of diesel very hot and the other one even hotter on water.
Yeah,
to make just make it longer. Put 2 screws on, two valves on if you need to valve it. But this is let's say the basic start kit to make work your ideas and make it better, and tell the other people how to make it better. So there's nothing else. Okay, well.
We're gonna demonstrate it.
I hope so. Here in Holland, yesterday there came some people from the Geet, www.geetnl, and they spoke to me.
Spelled just so.
Geet, Geet, yes, Netherlands, NL, and they have a website up, and they were very interested too because how do the stuff really works? And I only can repeat it. It's a small explosion with a big expansion of water, and the expansion cools down everything, and you can run any motor on this. I hope someday your bike, he's a very, very lovely Yamaha bike. I hope it will one day make less noise and less smoke.
No, not less noise.
Okay.
Not less noise.
Yes?
Yep. So when you see here in the bubbler, the water is mixed with the gasoline, and you can see the kit of the question is there's a vacuum. So this vacuum makes that the water evaporates at a much lower point, and this is a very and mix the water and the fuel together, and this fuel mixture is running through till the reactor. This reactor tube is surrounded by the escape. So it's getting hot inside because the hot escape from the motor is just running through it.
You mean the exhaust?
The exhaust, sorry, not escape, the exhaust. Wrong word. And so the exhaust is heating up the intake where the water and gasoline mix. Running directly into the motor without no carburetor is not necessary because this is a stationary motor. So here's a working model, so everybody can make something, and I just want to explain in a short way. It's a standard generator, but just bought from the shop, and the point is the Geet machine, like Paul Pantone explained, is in the part right, but in the part it's a bit different. So basically you can see here the liquids. In the lower part you can see the water. In the upper part you can see the gasoline, because gasoline is lighter. The hot air is coming in from here, going down to the bottom, and so it's bubbling. It will bubble up. Hello, well, I'm Andreas, or Luca, from the net. Maybe some of you on YouTube you know. I just want to explain the Geet machine as I did in Amsterdam. And well, I think the best would be just to show you now how it works. Can somebody hold it? Yes? Thank you. Oops.
Open the valve and just...
We have to oops, sorry, he's coming. Water out. It's water, yeah. Oh, and the transport. Okay, have a try.